Hi folks, I'm back on the road here. I took January off and most of February from the snowstorm, so I've been doing homeworks and can't go anywhere, so I might as well work at home, innit? And and do some more research on the computer about stuff I'm thinking about it and seeing and doing tests on it. But I'm just gonna that's something for people who like high frequency generator. I want to show some people how to how to do it. So what I'm going to do, and then after that I'm going to be talking about other stuff, what's going on with my generators and the wire and all that good stuff. So for now I'm just going to reset the camera and I'm going to show you how to get a very high frequency mechanical generator and how you're going to be able to put more volt out of it and to be able to use it as a regulated frequency, mechanical frequency generator. So I'll be resetting the camera. This is what I did. I just take a bracket for aircraft motor mount, and I just use a fairly large brushless helicopter motor, drum motor, and a very cheap one, a tiny little guy, brushless for chopper or small little plane, more likely to use it for. It's a very small motor, and I just want to see, if I spin that, what I'm really getting out of it, because they're not wind up for a generator, but I'll be able to see my frequency. So I'm going to start it up, and I put a little bit of load on it. I put those two bulbs there. They're 6 watt each, for automotive, the 12 volt each. So and I'm just gonna start it up and see. Now it's not so much volt coming out of it, because there again they're not made to do volt. They're made to receive a lot of amp. So as you can see, there we go, 11 volt to 6, all right? So I'm going to move that to frequency. I got 2.6 kilohertz, and I can crank it up to 2.8. Now those bulbs are going, everything is going, it's fairly quiet, and high frequency. Now the volt regulated from the RPM you're spinning the motor, and there's no two doubt about it. But what you want to do is, I got a bigger motor here, which I'm going to take it to the mechanic or the repair guy, and I want this guy who's got a puller to pull me that motor apart, so I can rewind. The stator, and instead of going with a large wire with multi-braid wire and go around, right? And every third one you go around, right? So you get four pull for each wire of those one, and then all the end connect together. It's a three-phase motor. But the controller we're using, the RC controller, he actually find where the magnet is, and he correct the magnet for a start. That's why you hear this loose sound coming out of the motor. You hear every time you turn the power off, right? Oh, look at that. Oh yeah, I gotta power down my power supply, and you will hear this, and you will see the motor position itself. I'll turn it like this here, and you'll be able to see it. So I'm going to turn that off, and I'm going to shut on the main power, and I'm going to turn it back on. Okay, now I'm going to position the magnet because the controller asked me, right? So he's going to, there you go, he confirmed where the magnet was, and he says go, right? And then we can turn that. So I mean, those are the little thing there. The motor makes the sound, not the controller, like some people think. So it's just bouncing, it's high frequency bouncing against the magnet. And I got it made up with my big drum motor. It comes from the magnet. They make the magnet resonate. But I mean, like, you know, it's small and it's fairly cheap to make. So if you even that one there, you would be able to create probably around about, I would say 24. If you rewind that tiny little motor, you should be able to produce probably about 60 volts at high frequency. But when you take that 60 volt and dump it into a step-up transformer, then suddenly, whoa, the volt just jump up, but you still remain your high frequency. Now you put that through a spark gap with multiply against, and then again, and then the sky is the limit, because my other generator here, the one, you know, I call the voter machine, only puts up 300 hertz. Can you imagine 2.6 kilohertz? Enter the step-up transformer. Obviously, you need transformer who can actually, you know, high frequency, or what they call those communication transformer, which are wrapped over each other, so the communication gets right into the second coil immediately before it gets absorbed into the iron. Because why the step-up transformer? Here's a step-up transformer, right? So 4-to-1. So whatever you put in a larger wire coil, 4 times of the volume you put into that coil will go into out of this coil. And the reason is he's using something to do that. Now transfer is not free. Let's say if I put 3 or 1 amp into here, because my voltage went up 4 times, my amp didn't go up. Nothing went up on that one. Matter of fact, I lost a shitload. It went down 4 times. And the reason that happened is that's the price you pay to work with iron. That's the cost iron charge you. I will resonate this. I will resonate and move the resonance from this coil to this coil, but you will have a cost into it, and your cost is your watts, your amp. That's why it's really, no one can make something who make more, because they don't understand iron is not your friend. Iron is your worst enemy. You can do that with a coil lap over, just like Tesla did. You can have a multiplication of coil and you wrap it inside the other, and you have exactly with no iron, so you don't have your loss. Just like the pole transformer. Pole transformer, you don't have a loss. It's just simple. The iron is not your friend. So now that's what I was telling you. If you people that are into high frequency generator, mechanical one, they work fantastic, and you can rewind it to make literally a higher voltage. Because higher it comes out of your generator, your volt better it is, and you get rid of it 1 wire, so you only get 2 wire output. This when you wind on your stator, it doesn't matter which way you start. It's left, full spool, go down, go to the next one, and you go right, full spool, left, full spool, right, all the way up to the end. So they have to be reverse winding. So that what is happening is, at that point, that coil transfer his volt to the next coil transfer, accept the volt and make his own volt and transfer both voltage to the next coil, and it goes on and on and on like this inside your stator. So, and then by doing that, the stator's got iron, so it takes away again. It charges every time you use iron. It costs you. It charges you a fee for a job it does, which you can't do by yourself. So you have no choice by paying the bill to go across that river if you want to get across that river, right? So I mean, like, you know, so it's pretty simple. Like, you know, probably costs about $25, $50 for the little motor, and probably that one about $80, $90, maybe more, a little bit more for that one. So, and then the controller, I'm just using a normal 60 amp controller. You know, works great. You know, you can run that thing for hours. So yeah, just for the guy you want to play for, to make a high frequency generator mechanical, that's the guy to play with. So there you go with the high frequency generator. That's going to be my next one to go into my gray box. I decided to go in higher frequency with a different transformer. So when that's all done, that will be this guy here I'm going to be using as a generator. So I have to get it apart so I can rewind it, and then that's going to be all reinstalled into my big gray box, and then we'll find out how far I can go on the frequency, and then going through the spark gaps. Then it turns from frequency to resonance, and again, resonance is not frequency. They need each other, needs something to be able to become what they are. You need resonance to make frequency. You can turn frequency, you can shape it to a resonance, just like the AC current, or the AC current coming up to the transformer is from the signal, right, which has been slashed at 60 times a second, but it's got a very high voltage, 14,400 volt coming into the line here, and at 60 hertz. But the hertz is a slash, is an on-off. But the power comes in. It comes in with a very high resonance, which I believe, and that's probably communication resonance or communication frequency at the high frequency. It's probably, I would say, the 55 kilohertz, right? Could be more. Who knows? You know, I'm not the guy who's going to go and put my my little earth meter to the big wire. I know what happened. Well, that's that when someone does that. But I mean, like, you know, it's interesting. You know, a lot of people I was watching. You know, since I'm down a little bit here and doing some small stuff, what's happening in the internet about, you know, natural energy and stuff like this. And I mean, there's a lot of people out there. I mean, I'm one of them. But you know, I don't see a whole lot of advancement since the last 20 years. Besides a little gadget, you know, some stuff you know run, but you can't extract nothing out of it. You're not going to make your car. You know, it's a conversation piece. Okay, I made that when I was 14, so I mean, like, that was not a big deal. But when I'm talking about making something that actually is useful, and a lot of talk, I don't see much. I mean, like, you know, a lot of people say, oh, well, you always talk, but you never show anything working. Well, I do have working prototype. You know, when you achieve 3,600 volts on the single generator, single phase generator, you know, that's pretty good, especially when the generator have no iron. So, and the slasher works perfectly. You know, we just have to crank up the voltage. We're having this big dilemma with wire. Hopefully, like, you know, I heard that before, so I'm just crossing my finger. Hopefully we have a contact for wires, because we've been blacklisted on just about every single wire. They want to charge us like $5,000 for coating a tiny loose spool of wire, $7,000 for a loose spool of wire was already coated, but it's, you know, it's not the exact coating we want. So I mean, it goes on and on and on, like, you know, and I mean, price, ridiculous price, right? Well, I mean, like, you know, that's how the world gets suppressed of everything, right? Put a price high enough, you cannot afford it, and it doesn't matter how good it is. You can't afford it. You're not gonna buy it. So, but it's very interesting if we have the proper contact for wire. We're gonna test multiple type of wire, not just aluminum nickel. It's going to be nickel alloyed, copper silver. It's got all kinds of platinum nickel wire. It's a lot of wire we won't be able to test. And every test is, we don't have to make a whole bunch of coil to test in our generator. You make one coil, one donut, you slap them inside there, and you spin it at certain RPM, and you read the voltage coming out of the coil. And we can test all those things without having a big cost of taking the time and making all the coil. We can test what's the value of the wire for the same amount of wrap, same size wire, how much more, how much less volt you make at a certain RPM. So that gave us a base of table for calculation. But that's going to be done hopefully shortly by the end of this month. And we have a couple of other tests on different cell. We're still working on my cell, but on my cell I discover we don't need water. Water was a way to understand how gas work, and that's what it got me to understand when working my fuel cell. My fuel cell is in the stage that they're studying it right now. They want to make sure whatever it is, right? I mean, like we didn't get a motor to run, a big motor to run, which 80%, I knew it was not going to run on a big motor. I was going to try in a single cylinder, so we can see if we can get the motor idle. And this more likely the gas coming up of the cell will idle a vehicle, will idle a motor, but you cannot put your foot on the gas and ask them to go faster, because the cell cannot produce more. I mean, you can run, look, right? Just disconnect all your electric, not lefter, but your injector, your electric injector of your vehicle, right? And the side of your intake manifold, you will have a couple of hoses tied up to it. One's got about a 3/8 of an inch, right? While on the side of your motor, you will have your fume catalytic for your gas tank, right? So you have a vent coming up from the gas tank that was about 3/8. Take that vent out, plug it in to one of those input there inside of your manifold, right? And all you inject out is good and go start your car. And surprise, surprise, your car will run on gas fume. Now it's not liquid, it's in fume, but it will run your motor in idle very nicely. So I mean, like, those are the stuff, like, it works, but then on demand to getting more power, it's a little bit harder to do. So what I come out with is literally to be able to, which we're working right now. We have a gentleman that's fairly knowledgeable about what I'm talking about, and is an expert in electronics. So I finally find someone who want to work with us, and I'm going to explain exactly what I want. We have to be able to prime the nitrogen that the motor sucked in, right? Because when you crank a motor, it creates a vacuum. It's just, we all know that, right? You put your hand over the end of an intake of a car when it runs idle, and it just sucks it up like a vacuum, and then you kill the motor. So we all know that, right? So if I can prime, because priming the nitrogen before intake is kind of risky, the way I prime it, because nitrogen and the air react in a funny way. They're like sister, and like twin sister. One doesn't matter if they're two twins in the same room. If one think about something, normally the other one will think the same way, right? And it's been tested in college and all that, university and research center and all that good stuff. So the nitrogen cell is the same way. It can be told, can be giving a message for an action, a reaction, or a release. And to me, I see it as a primer. How do you prime this nitrogen? Because the fuel in your car, that's all it does. It primes the nitrogen. Nitrogen is the largest volume of anything going on the top of your piston is nitrogen. Okay, I mean, just look at it. It doesn't have to be a rocket scientist. We're breathing 80% nitrogen when we breathe. So obviously the motor is going to do the same goddamn thing that I'm doing. So I mean, like, you know, if we prime the nitrogen under a negative atmosphere, this means after the throttle body, because that's what the vacuum appear, the negative pressure appear after the throttle body. If we can just prime that nitrogen at a certain level, you don't want to prime it too high, you don't want to prime it too low. It's got to be primed in a certain release of energy, and the frequency will do that, or the resonance will do that, and that's why I'm going to be working to create a resonance transmitter, but not wireless transmitter. It's a transmitter, just like the old phone, right, with the cord and all that. Well, that's all, you know, going through the line and all that stuff, just like this, right? So it's going to be, you know, transmitting a resonance into a fork inside of the intake manifold at the negative pressure side. And if we can tune that properly, soon if we have the right tune, soon the motor starts sucking that air into it. 80% of that nitrogen will be primed at a certain level of explosive. We will only ignite with a high voltage discharge or lightning, which is going to be your spark plug in your motor, or under compression. I don't know yet, but that, you know, that could be worked out into the equation. And same thing with the diesel. The diesel, you know, the diesel literally just prime the nitrogen. You know, diesel by itself you can't light it up. Gas by itself you can't light it up, right? I mean, I'm not making that up. Try it up for yourself. You know, it's just not fuel, but it's a primer. Well, the primer is not the fuel. The primer prime the fuel to a certain level of release. And this is what's going to be very important in the next couple of months here with the guys across here, and what we're going to be able to achieve. And, you know, it's a lot of stuff that's going to happen. That's going to be looked at pretty hard, and it's not a very, apparently, I'm not an expert in electronic, but he says it's not a big deal. And we also finally said he have no problem if we cannot get the hind controller working properly. He can make the home controller out, because I know the recipe what you have to go into the motor. You know, I know whatever we put in the inside the controller, so much of that have to come up in a certain different shape and form and timing. So it's all about timing. Soon you get mount set and a system, you got timing. So I mean, like, you know, it's you know, unless you have the reverse reading like the RC control, which doesn't have mouse set in there, right? Which happening is they're reading, they don't push any power into it, but they're reading the microvolt coming out from which wire, and they find out exactly where all the magnets pretty much are, and they will place it at the right place for the motor to start, so it doesn't just cock back and forth. So so that's pretty much the same thing, right? You know, those drum motors are the same configuration, same thing you got in your hard drive on your computer, same thing some of the high-end watch have, because, you know, the step-up motor we call, and then we can convert step-up motor to a motor, because the motor is a motor. Either moving 136 of a turn at a time, it would move, you know, faster, you know, and then that can create your rotation. So I mean, if we got you know, this electronic guy says he can work with us, like, you know, we're gonna definitely put it to work, because this is very important. That motor, the drum motor is very important. The generator, the wire is very important, and replacing the fuel cell so you don't need water, because listen, nitrogen is 3 times the physical size of the earth. Water is not your biggest mass on this planet, okay? It's a good chunk, but it's not. Nitrogen is the largest mass on this planet, and we're breathing it. I mean, like, you know, it's the air we breathe. So we're just nasty beasts, that's all we are. So, yeah, and there's a few people, they asking me, I was finally got to catch up on my comments and stuff and email, and they asking me, wanna be able to show them how you're dissolving, like literally powderize tungsten steel, right, with a high frequency. And I have to wait to get my generator back so I can demonstrate that. And it's not a problem. If it's not under vacuum, they just vaporize, just like the 9/11 tower. They just disintegrated, right? Steel disintegrated, everything disintegrated, right? It's just resonance. That's all it is. Resonance can do that to steel and all that. So 9/11, it was a perfect example of that. I mean, you have people, you know, they were almost floating in the air and this dust, you know, and car from far away, they were burned because only the metal was burning. The paper was not burning. All the paper was just shooting all over the place, flying but not burning. But the car, you know, close to the tower, all the car were burning. I mean, like, you know, anything that was metal was burning. So I mean, like, you know, then you see piece of steel still standing up and then still go disappearing in thin air. I mean, those are the videos have been, they didn't get debunked or nothing because they can't debunk it. That's the way resonance works. That's how Tesla could do a massive amount of stuff, you know, because the bugger, he got into, he understand the resonance. And the more you make a wire resonate, with better element you have to resonate, more that power shows up around. It's massive, you know. And a lot of people, they call it RF leak, RMS and RF and all that stuff. It's resonance. Get over it, you know. It's just bloody resonance is leaking. You know, that's all it is. I mean, you can recapture the resonance and reuse it. I mean, it's just, you know, it's an energy, it leaks out. And that's what you feel when you're walking into a room and the resonance, it's just like, you know, you can feel it in the whole of your body. Your whole body start to feel the resonance. And I mean, like, you know, obviously it's not that bad because I've been playing with this stuff for now over 2.5 years and I'm still alive, right? And I have my daughter live here, and the cat, and somebody else underneath here. I mean, like, you know, and the neighbor, they've been doing just fine the last time I talked to them. So I don't see any problem with that. I think we've been lied extremely, you know, by the people, or just profit of, you know, selling your energy. But I hope more people are going to do their own research, you know, and coming up with different technique and how to do it, different idea, because, you know, spinning something, you know, we all know it makes energy and stuff like this, and we know, I mean, I prove it many times here with my big generator, you know, producing over 100 amp with, you know, roughly around about 6 to 7 amp on a 14 volt input. So I mean, like, you know, this is amp under load. We're not talking about, you know, when you check the volt. I was melting, literally almost tungsten steel. So I have to bring that very close to 10,000 degrees. You know, for one 1/8 rod. There was two 1/8 rod there, and to keep that red for as long as you want, you know, you need about 40 amp to do that. That's at 240. So I mean, like, you know, it doesn't make sense, right? You know, and that my generator have no iron, absolutely no iron in it. The only thing it's got iron in it, as in the generator itself, is the 4 magnet. Of course, you know, magnet is, you know, the magnet we know how they're made based on iron core. So I mean, like, you know, that's the only thing. But the magnet field, like, you know, they don't have a field around the magnet. The field is strictly, it's not moving. They don't even connect each other unless you put some steel in between or wires. They don't flow. It's no motion around the magnet. So the brush, the magnet is almost like an invisible brush on a certain string who scrape across the wires. right? And that's all it does. It just creates a whole bunch of resonance into that wire, and the wire convert resonance to volts. That's the conversion. Or any wire with any type of metal will convert resonance to volt to a certain level. So I mean, like, you know, this is a very simple process. I mean, everybody's overthinking all this whole shit here. You know, how the electron flows. You know, fuck all that. You know, the electron don't fly up and down. If every electron would fly up and down, everything would be floating in this room here, right? We wouldn't know which the bottom to the top if the electron would flow. No, the electron create mass. You know, this is a big mass of electron. It's a mass. It's got weight. It's got gravity. It's a mass, right? Those are electrons. Electrons do not flow around you because they create mass. Now you can move electron, you can create electrical electron through a mass and move it through another mass and then recuperate that on the other end. That we can do because that's how apparently we're making power, right? So I mean, like, you know, electrons don't float. I mean, like, you know, everybody have their own theory. I mean, same thing with me. Everybody's like have his own theory, but everybody, just like an asshole, everybody's got one. So I mean, like, you know, but you have to just use a little bit of logic and how the whole system works. It's a fucking lie the way they tell us. I mean, if I ask any scientist, explain to me how an electron go from point A to point B, right? And then I say, okay, so you know how to do it, right? And you take it to a lab and say, okay, now what we're going to do, we're going to put this thing together so it does exactly what you do. They're totally lost. They don't know shit about putting something together. You don't see any whiteboard. Someone brought me a whiteboard that's beside my fridge. I never use the damn thing. You know, I don't use whiteboard because I'm wasting my time writing stuff and idea on a whiteboard instead of doing it. Now by the end, all I did is write, but I never prove anything. I want to know if it work or not first thing, right? Before I put it, you know, I put too much time on it. So I go to the simple way, smallest way, you know, so it doesn't cost millions of dollars to do it, and do a test, and then, hey, it doesn't work, or hey, it worked. You know, that's cool. So now then you start doing more tests with it, because now you have something to actually give you an output, and it's a different way it doesn't work like AC work. And then you start asking questions, and then you ask more questions, and every time you answer one question, you get another 200 to answer, because it keep on coming. You know, it doesn't stop, because it's just like, you know, it's just like you opening a door. You know, question number one is behind door number one. Soon you open that door, you go into a room who's got 10 more doors. And you have to answer every goddamn door before you can get out of that box. You know, and only logic can do that. Because hell, mathematics can't. You know, it's in the box, and I mean, those guys, they have 6 sides. That's mean top and bottom. They can't get out of that box. So I mean, it's just a question of how you see, how you perceive, your perception of things, how they work, right? I make it very simple. I mean, I make it like just like, you know, like what you see around you when you're sitting in the yard and watching a fly flying, or watching a butterfly, or a hummingbird, or whatever, right? You can see with your own eyes the motion and all what's going on. That's most likely what I work with. Call me Judas if you want, but I need to see and touch before I really believe. So I mean, like, you know, there you go. So this is how I work, right? I mean, I will listen to anybody. I will look at everything. I mean, we can do demonstration. You can do some tests, you know, recorded tests and stuff like this. And yeah, I mean, like, you know, if someone's got something, let's show it. Let's see it. You know, I have no problem with that, because I'm not in a race. I was never in a race in the beginning, and I'm not in a race now. So I don't care who gets there, or who gets out of the finish line. I don't think it is a finish line, because it's going to be a continuously challenge for who is going to come up with a better way, less moving part, no moving part. You know, I don't know. Like, you know, it's not a race for me, because I don't really give a damn. All I know is I find out a lot of stuff does not work the way they say it works. Instrument don't tell you shit because they've been built to tell you exactly what they want you to know, not exactly what's happening, right? So I mean, like, you know, there's a lot of stuff we don't agree. You know, a lot of stuff I don't agree with people, and a lot of stuff, you know, people don't agree with me, or you know, vice versa. And that's, I don't care about that. You know, it's just it's just the biggest problem is to get the goddamn parts, get the damn wire, and get, you know, this is the biggest frustration of all for me. Is how little parts or material we have in North America. I'm surprised. I'm surprised the poorest country didn't invade Canada, because we made nothing to do anything. Literally, that's why no one invaded Canada. You know, I'm surprised a seagull fly, you know, normal. They should be flying upside down because there's nothing good to shit on in Canada. Literally, that's the reason we'll never be invaded. It's nothing to come and pick up here. You don't come here to pick up good stuff in Canada, right? So I mean, like, you know, look at it seriously. And if you don't believe me, you know, learn your history. You'll know what I'm talking about. So, beside that, hopefully, like I say, you know, in the next couple of weeks, I might have some information on what's happening over there, because I'm going to be doing Skypes, you know, more of the time on all the tests, and then see what's going on with that. So, in the meantime, we're just keeping on plugging on it, and hopefully we'll have in the next 2 or 3 months we'll be able to see light in the end of the tunnel. So as long as we got the wires, I think I would have no problem, because I believe so. The wire will make an extreme difference, especially in the later years of Tesla, when they were working with very fancy, we call it fancy material wire, which they was called in those days. You know, because they didn't want people to know about it, but I'm pretty sure it was definitely nickel alloyed, because they had nickel in those days, so they could do that. And I'm just going with what they had at that time, right? We're talking about the turn of the century here, so I mean, so it was like, you know, let's say 1910, 1918, right? You know, it was really going fast, because, you know, a lot of things was happening at the time, and more alloy was coming up, so you can have more alloy wire made up. And those days, to say, can you make me a couple of 100 pounds full of wire in that size? Well, for them that was like, yay, that's a day's work over there, right? For the factory, so to produce that. So yes, it was no problem to get that done very fast. So, yeah, you know, it just, it's sometimes it's depressing. The reason is a lack of parts, of material. You know, it will really stop you right down your trap. I mean, like, you know, what you do when you're looking for something, you know, you feel like you're looking for something that doesn't exist. You know, you're going crazy, you know, come on, you know, then you just do your research. Oh yeah, shit, you know, it's right there. You know, matter of fact, you know, it's 8 type of wire. When I'm looking at the chart, I want to try every single one of them, right? I want to see what it puts out, so that way I have absolutely everything, you know, because we can't find what the wire would put out. For some reason, it's not something it's mentioned in an electrical engineer. Is a different type of wire and what they produce on the generator. No one knows about it apparently. I'm pretty sure they do know. They just don't want you to know. So, but this will be able to make a scale and all the tests and all the wire we're going to be able to test, and then we'll be able to put it out there so people can say, hey, why we've been using copper and iron for all our life so far, right? So I mean, like, you know, it makes no sense when you can produce, you know, a lot of power with no iron, because iron is a pig, and it charges you a shitload of energy, you know, just to transfer from one coil to the other. So I mean, like, you know, it's just a massive amount of loss you get there. So that's why the transformer over you know, it's a better shape, better conformation, because it's just like the pole transformer. But if you use proper wire and use proper layers and how you do it, and use instead, you know, to use I would use literally a graphene block, which is I think I got a set here. I put not, oh yeah, there it is. I was going to test that. This is a mechanical core for making transformer. So, you know, you can pull that apart, and it's two-piece, so you can make a nice core, oh, you know, and then plonk it back together. So I'm going to use that because that was for a transformer, a high output transformer for an ozone machine, for the negative ion. So I'm going to try that next time, because that's just worth to be tried with. So yeah, it's, you know, and there again, also transformer, you know, understanding what is a transformer and how they work, and how a pole transformer works is very important to understand. You know, when I did the test there with that Lou McCulloch generator, you know, and I was putting I think it was 1400 watts, and I was getting like something like 3600 watts on the load on the other side from jumping through two pole transformer. And some people, they still couldn't figure, they try to do that with a different type of generator. Those generator, the flywheel generator, bipolar current, they're RF volt, okay, to create no friction with magnet flashing, and coil with no iron. Matter of fact, I got the coil right here. Those are the coil, right? The magnet goes through. No iron in there, nothing at all, just aluminum holder to hold those two coils like this, and the flywheel goes on each side of the like this here. It fly like this, and it's a north-south, and it's four magnet in the flywheel, and that's why you cannot burn those generator. We call them in the military, you know, the stupid generator, because no stupid can really burn it, because if you put too much load on it, you know what happened? The light bulb, the other light bulb getting dimmer. You put another light bulb, and everybody is going to it like a candle. That means you reach the maximum. You'll never burn out. They have a 10 amp fuse, and generator, that fuse never burn. It's just because they had to sell the unit. So I mean, they cannot, and that's why when there's no friction and there's no iron, you create a communication current or a communication volt. And this is all, you know, I learned that by playing with this shit, because it didn't make sense. It didn't make the same thing as the one from the wall. The one from the wall doesn't do that. I plugged two large transformer to the wall. I was able to double my volts. I was making 240 out of 120 output, but I was staying right on my marge for the breaker at a 50 amp breaker. I could not make more than 50 amp on the outside, so I was not multiplying my amp, I was only multiplying the volt. But again, right, what you think is in the transformer, they wrap internally a shitload of iron again, right? So that bloody iron is not your friend. You know, it's taking everything away. That's the cost of using iron. So all I would do, you know, at that point in time is really study, you know, how communication volt works, and you will find out, you will learn a shitload about it, because communication volt is a totally different volt than anything. And then also when you find out, then the magnet, the polarity is actually not a moving field, but an attraction. And it's not a field, it's just a straight attraction. The same thing with the pole, the field of the earth. It doesn't move, because if it was a field, we would call the North Field, not the North Pole. It's just an attraction. And then for the person who says, no, how come I get a compass when I go on the water? Well, I like you to take your compass and go for 1,000 miles on water and find out where you're going to end up. We stopped using that in the mid 70, late 70, because people were getting lost. So that's what GPS had to be brought up. We have 3 North, if you don't know about it. So you can go a magnetic compass on the sea right now. It's useless. The plane don't use it. Nobody's using it because they'll put you in a circle. But anyway, have fun pedaling in the middle of nowhere. Yeah, I mean, like understanding the north and south, when you know that the field is not moving, it changed the gameplay. It became more then you can see how things work, and playing with the cell and see the different gas I was making with that cell from different pressure. Yeah, it makes sense, because when you put something under pressure, you change the gravity. So change the gravities, well, that material will change if you reach the right gravity for that particular material coming out of that gas. And that makes total sense at that point in time. That's why, we don't have to make a cell. We just have to, I know what's coming out of the cell. It was the gas. You don't want to use the gas. It was the radio frequency she was pushing out. When my buddy in the States there, when he was testing the cell, and he was having his headset coming up, and I could hear that high pitch when every time you get closer to the cell. And he could not hear it because it was transmitting to me, the unit is transmitting what it's hearing. So if I had a high frequency jumping on a transmitting way, then I would hear it and he wouldn't hear it. So when I find that out, that was another big break. It takes always a little thing to make a big break. It's about understanding stuff. And that's what I thought, oh my gosh, it's the resonance comes out. So, I mean, everybody call it photon, I call it resonance, because, if I see a chicken going across the road, what I would call it a pig, right? So, I mean, it's a chicken. So, that's what I call resonance the way it is, resonance. And understanding the level of density of a resonance and the volume of resonance, and be able to visually see it, makes absolute sense, how everything works now. So hopefully with the crew we got in the States, I will be able to put stuff together pretty fast and doing some tests. So in the meantime, that's what we got. So hopefully it was not too long, but you can't explain stuff like that in 2 minutes. So I will want to mention to you also about a little bit about what we call potential. And a lot of people, I think they have, everybody's got a different way how to see potential, but no one can figure it out how to create it, or how to extract it, or how to convert it. Well, how to convert it, we already know that, because that's what's happening into a pole transformer, and as I showed before, a pole transformer is a transmitting antenna over 3 receiving antenna, X1, X2, and X3. So, but how do you get amp out of a transformer? Was the potential from the high voltage, 14,400 volts coming in a transformer. If you want to know how many volts, it's very easy. If you want to know how many volts you need to make 240, right? And all you have to do is find out what's the cycle of your equipment, 60 hertz. So you take 240 times 60 equal 14,400 volts. That's what you have to dump in the transformer to be able to maintain 240 volts. And if you want to make only 120 times 60 is 7,200. So this is the amount of volts. It's a very simple calculation. So it's not that complicated. The potential comes in from your power line, from the top of your power line. have to have first thing, have to have the voltage to be able to do the conversion from the transmitting antenna into the plate. The plate is surface of so many square inches surfaces. You know, when you dump so many volt into it and a radio frequency transmission, it's converted into, it brings down the volt down, and then the potential convert itself into watts, which, you know, calculate 2 amps down the road. So the density, find out how you can duplicate that, right? Because that's all I'm doing is duplicated a power plant and miniaturize it to run a house, right? Instead of, you know, it'd be a big dam or whatever, it's just you miniaturize. But you don't need to send a whole lot of volume. You don't want to create a river. I just want to have a small little creek, right? So all I have to do is, in my generator, is to be able to create enough resonance. That's your potential. Now everybody said, oh, that's a frequency. No, it's not. Resonance can make a frequency. You can take resonance and shape it to a frequency, but it's only going to be shaped like a frequency. It will not act as a frequency. It does something different because it carries potential. A frequency doesn't. A frequency is a sine wave, right? You know, I don't care how tight or how lucid the sine wave is. It's a sine wave. You know, that's what, you know, your frequency, square wave, whatever, AC wave, you know, high frequency wave is just the line. The line is tied up. It might be bent, but it's still connected together. And resonance is not. Resonance is just like if you look at a piece of paper and you see an AC wave, it goes like this, right? If you were looking at a piece of paper and our screen is frequency on it, it'd be trillions of tiny little black dots on the screens. That's what resonance is. And frequency would be your line. So potential is how many of those little dots can you fit in a square meter, right? Like I explained to a friend of mine, like, you know, if I have a box of BB, right, and the box is a square foot full of BBs, right, those little pallets, right, full of BBs. Well, I have volume because each BB gave me a number, right? So I have probably a couple of million BBs in that little box, right? And I have potential because they're all tied together, right? Now, you say, well, now if I take the box and I go to a beautiful and a nice clean room, like, you know, and the floor is perfectly flat, right? I go in the middle of the room and I drop the box of baby upside down on the floor, and you see all the babies scattering all over the place, right? I still have my volume because I didn't lose any baby. But I have no potential anymore because it's all gathered up. So, and to me, like you say, oh well, it's hard to see. Okay, let's take that same box of babies, which is literally a square foot, literally, of solid copper. Right? So it's going to be heavy. If I drop the box on your foot, I'm going to break your foot. That's called volume plus potential. But if I pour the baby on your foot, right, I broke the potential down, I reduce it to barely nothing. All you're going to feel is a little bit of weight running like water on your foot, right? It won't hurt you, it won't break any bone or nothing. That's how potential is. The resonance have to be very tight, very compressed, so there's no space in between. And when it goes into the transformer with the 60 hertz slash, it goes into the transformer, that resonance decompresses itself and create amp in your plate. The volume is still there, and the plate, the surface, the square inches of the surface of the plate will drop the high volt into the 120. We know as each plate will be X1, X2 to 120 each, and X3 is your neutral. So now we have a way to see things. You know, before a lot of people they're talking about potential. What is potential? How can we refer potential when you can't see nothing? You know, everybody is an expert on telling me how the electron work. and I look at him like, like, a stupid look, literally, because how the fuck can you tell me something you cannot see on operation? Because no one can really see the electrons working. I never see a real video of a working electrons under X-rays. We can't see it. How can you tell me what it look like? I mean, everybody says one little ball is got a plus, one little ball's got a minus. For me, an electron is just a piece of something which is actually positive and negative. So they can cluster, because an electron, all an electron want to do is create mass. That's a whole pile of electron, rolled up, heat up to plate and compressed, cut and stamped and compressed together to make one big chunk of electrons, right? So it was manipulated. It was not natural, but it was manipulated. But it's still a big chunk of fairly pure electrons, ion electrons. And the same thing with this here. Aluminum, different electrons. Copper, different electrons. Brass, different electrons. You can do the whole thing with brass, copper, with a magnet sliding on plate. They all have the same effect to an iron magnet, because the iron magnet have no attraction. All it have is a resistance. Why is a resistance? Because the field of a magnet is not, field of a magnet. Let me correct myself. The polarity of a magnet is north and south. It's a polarity, pole, okay? That means attraction. It's not a field. So if it's no field, that means on each end of the magnet is going to be a little hair like this. And the electron of that plate have a little hair to it, but they don't like to stick together. There's no attraction. But when they go, and again, like they go through each other, it gives you a resistance, because it's just like taking two brushes and brush it against each other, nice and slow. It gives you a resistance. So we're gonna have to understand, if you want to create an electrons, right? You got to find a piece of material and just squeeze and melt it together. That's how you make electrons. I mean, it's no other way. Like the way things work, I could not make anything work the way you guys explain how an electron works. I'm achieving stuff people cannot even explain how the hell I'm doing that. Everybody who came here in this shop here, right? Everybody who came in this shop here and I did demonstration, they walk out of here shaking their head out. How the hell can I do that? Because they don't understand how electron work, or if it is an electron. I can't see it, so I'm just playing with the word electron because I don't have another word, because I cannot see it. For me to say something, explain how something look when I never see it and never been explained or show a picture of it, I would make myself look like a fucking jackass ass. Oh, that's right, I forgot. Sorry, the scientist does that all the time. Because they're assuming stuff without seeing it. Same thing, they're talking about the universe. Well, I don't know, the last time no one offered me a ride to go to the universe. They take a good look how the thing looked from there to here, from there to here. I don't know. I never been there. So I mean, like, if we just stop pretending, and that's what there's a lot of pretending on there, pretending knowing how thing works. Instead, try to duplicate what they tell you how it works and see if you can have that effect in the end. And if you cannot achieve that, then you've been told a lie. Just like, that's why people can never find, free energy, natural energy and stuff like this, because they teach you how to look for something that doesn't exist. That way you can never figure it out. You know, it's that simple. I mean, the mystery is over. Like, you know, what you learn, how it works, it's not the way it works. So now, if you don't sit down and start doing the kind of shit I'm doing to just try to find out why, you know, it's not happening, it's happening way different. Oh my God, I can get way more than that, you know, with this and all that stuff. It's just because I put shit together, you know, and I try it. You know, sometimes you said, oh well, I mean, like, you know, let's try it. And sometimes you think, you know, you'll never see anything coming out of it. And then, wow, the result is like, holy shit, how did that happen? Well, because you were expecting something from something you've been taught, which was a pure fucking lie. So, I mean, like, you know, that's why, you know, like, why do you, on a transformer, right? Why you lose your amp when you go to a step-up transformer? Because every time you step up, you lose your watts, right? Your watts goes down to, you know, I mean, you lose like 60 or 80%. It's kind of crazy anyway. So, I mean, like, you know, why? Where the hell the watt went? Right? Where the fuck it went? I put the watt in here, and I get higher voltage, but there's no burning nothing coming on when it comes to watts. Where the fuck it went? Yeah? Any fucking scientist can tell me where the fuck it went? Well, that's what the iron charge you. You want to pass a resonance through me, because now you're just pounding me with a coil, so I have to resonate at a higher level so I can pass the resonance to the other coil wire. So you will amplify because it's a smaller wire and it's got more length, more footage, more volts, right? So he said, I'm not to do that, I'm going to charge you something. I'm going to absorb your heat. And that's what exactly, it's absorbing all your watts. The iron does. So that's why iron is not your friend. And that's why a lot of time we don't understand Tesla is transformer because they had no iron in it. All this new transformer, when they say it's a ring of iron, it's not. It's a ring made out of wire. It's a wrap of wire, you make a donut out of it, right? And then you tape that to insulate, and that wires have to be insulated also. It's a winding wire. And then you take another type of wire and you wrap right across around like this, and you make yourself back and forth like a horseshoe on the first ring. Now you're going to have two wire coming off from the ring, two wire coming off from the outside wrapping, right? That's your high. The one from the center is your higher voltage. The one, the low voltage, you're going to pound to step up or step down, and you should have, you know, your watts will probably increase by 3 to 4 times by removing the iron. You're still going to lose some, but at least you're not going to lose so much. And that's why, you know, I'm going to start playing and making different type of transformer with no iron in it. So, you know, it's a hard winding, because the winding you have to have a ring pretty big to be able, or get yourself a winding who can wind small donuts, right? Small donuts coil, and having a winder like that to wind the outside. But it's a tough goal anyway. So but I'm going to try that and to really see if I remove the iron, can I gain back some of my what I lost. But there was a lot of stuff of Tesla was literally, how can I say, false. Some of the drawing of Tesla, if you look at his signature, that's not his signature. I mean, it's 6 different type of signature in all the Tesla document I have. And this guy, you know, he was an expert at signing his name. So a lot of the stuff, I would say about 85% of all the information of Tesla is literally a true lie. Like, you know, it's nothing to do with Tesla. It's just sending you into a different direction. But a lot of the stuff I'm looking at it as, you know, they have no explanation of what is it. And then I find some older document, and then suddenly I said, that's not a piece of iron. It's just a donut of wire, and with other wire wrap across of it. I said, that's different. And then they don't ever show you, you know, he had a shaft in the middle, with 2 magnets on it, and it was spinning that inside that thing. And guess what they call it? That's your distribution generator. So I don't know if the word distribution generator is right on it, but that's what they call it. And to me, it would make more sense because every time you see a G in Tesla's drawing, that's mean high frequency generator, and that's what you run is unit with high frequency generator, and I believe that is the makeup of the high frequency generator talking about with the 2 magnet. When I saw one of the drawing, it was a real drawing, and it had 2 magnet. It was a shaft with 2 magnet on it, and those days they had very poor cast iron magnet, but they were magnet, and he was spinning that inside those generator. They were about, I would say about 6-inch diameter, and probably about a 4-inch hole in the middle to clear the coils. So he was spinning a shaft with 2 magnet on it. So and very little explanation again, and again I don't believe literally nothing about the explanation. So before I do the test and work that way. Same thing with my Tesla coil. I mean, the Tesla coil I made is not one to make lightning. It's a communication coil, so you can dump it in a very high frequency and be able to transmit, literally resonance out of an antenna. And that's what Tesla was doing, transmitting, seeing how far it will have effect. So, it takes you a long time to be able to absorb and go through all the trial and error. So, but hey, that's the way we do life, trial and error. Because if you don't try it, you'll never know if it was an error from the beginning in it. So, but anyway, that's I wanted to explain a little bit more about the stuff. So I just, we're going to be making a very high frequency generator by getting that drum motor, my airplane motor, pull apart so I can rewind the inside as a generator. And that's going to be interesting to see how much frequency I can pound and voltage I can pound into this transformer to see what kind of broadcast, to be able to test how far with electronic it will affect your electronics, and what kind of effect it does to it. Either freezes it, like I've been doing it, freezing it. I freeze electronic, solid. So I just want to know how far this thing can be, and how can, when we find out, we can stretch it. How can we control it, right? And how can we absorb that? How we can use this energy. So, but on that point in time, that's all pretty much I got. The crew, I think they're going to get together by the end this week, so hopefully we'll have some stuff working out and working on controller. So that's pretty much all I got today. So we'll catch you later.